All right, let's get started. I know there's another keynote in the ballroom 4:15, so let me try to make sure I complete it and you have time to walk over there. So anyway, hi everyone, Kelvin Low. I'm the Vice President of Samsung Foundry for US. I basically do market intelligence, business development, business strategy. Obviously, today we're going to focus on RISC-V and of course the extremely important keyword AI as well, right? So I'm sure all of you have seen some form of this slide, just a bit about the market trends. A busy chart, but let me quickly orientate you to the data points here. On the blue line, the light blue line that you see, those are basically AI model sizes in parameter count. GPT-1, as you know, is about 170 million parameters, going all the way up to GPT-4, about 1.8 trillion parameters, right? So the more parameters, the more compute power you require to train these models. The green line shows you the teraflops for AI hardware. So you can see the obvious visual gap between the blue and the green line, where we require, or the models require 10x per year improvement, where the AI hardware is only improving about 2 to 3x a year. So one of the key challenges to handle AI models. The second, I would say, probably more important challenge that we have. This morning I was listening into CNBC. There was a discussion around US hyperscalers already in advanced discussions with energy companies, right? And guess what? To bring up SMR, I'm not sure whether you heard of this acronym, small modular reactors, right? So we're going to use nuclear power to basically run these very hungry data centers at a massive scale, right? A lot of data has been published, right? Whether it's kilowatt to megawatt to gigawatt, basically consumed by this, again, future devices. So a practical challenge that has to be solved, right? And then the last, maybe not as heavily talked about, but super important, right? Is memory wall, right? So the data actually shows you basically compute flops, right? A trend, and the gap has already existed even pre-AI era, right? With AI, obviously, there's even a larger gap, right? In the last 20 years, compute flops has grown about 90,000x, where the DRAM bandwidth, for example, has only grown 30x, a significant gap, right? Not to be discussed in detail today, but we definitely require better interconnect solutions to solve this practical gap. Okay? So what we actually have a booth here. In fact, Samsung Foundry is exhibiting at the RISC-V Summit event for the very first time. You'll be wondering, why is Samsung Foundry here? Because we do not manufacture products. However, we actually enable a lot of our customers that has embraced RISC-V, and we're also talking to the ecosystem together, right? Without the ecosystem, product innovation cannot be properly realized. So what you see here is a simplified roadmap of our advanced technology, 754 nanometers. We have been running them with FinFET device technology. At 3 nanometers, we basically implemented gate-all-around, right? We call it MBC FET, multi-bridge channel FET for short. And I'll describe a little bit more detail for some of this technology. So 4 nanometer, right? Just zooming in a bit more. We have a couple of variants, 4 nanometer SF4, SF4P for more performance. We are in high volume production today with stable use and with additional enhancement, right? We continue to basically evolve and create additional features on this technology. For example, SF4X for even higher performance application in AI, and SF4A for automotive applications, especially those that require advanced processing for zonal controllers or even higher level ADAS, right? We will basically also couple this with our additional, our advanced packaging solutions that I'll talk about later. So a lot of the applications our customers are in the consumer mobile area, data center, and automotive for 4 nanometer. We were extremely excited a couple of years ago to be the first one introducing 3 nanometer gate-all-around. So this, again, this technology is in mass production. Key end markets and customers are basically from the HPC, automotive, and mobile area. Obviously, not stopping there, we also have introduced 2 nanometer, which is our enhanced gate-all-around. We're pushing our gate-all-around leadership further, basically doing other additional innovations like optimizing effective capacitance of our devices, or even introducing, let's say, lower track standard cell library, more on DTCO, right? We try to maintain as much IP compatibility from 3 nanometers. So again, some of the usual suspects applications, again, HPC, AI, automotive, and mobile. Okay. So come to packaging. So we have some displays actually at our booth. This slide shows you what we are doing for iCube. iCube is for horizontal integration. So we have 2.5D to 3.5D for our versions, what we call iCube S, silicon interposer. We are already running production for 2x HBM, 4x HBM, preparing to run high volume for 8x HBM, and basically in development for 12x HBM. You may think this is pretty insane, going up to 12x HBM, but this is a necessary request from our customers in this area. For even larger platforms, we have additional variants like iCube R. R stands for RDL. And iCube E. E stands for embedded silicon bridge, right? These again will allow us to stitch additional logic and memory dies on the same package. Okay. So, and yes, we believe we are the only foundry that has a one-stop solution. I briefly introduced our process technology. We also have our Samsung memory division that provides advanced memory like HBM to customers, right? Remember I said memory wall earlier in the introduction? So one of the initiatives, and in fact active activity right now is doing HBM custom-based die. So there are tricks that we can do, marrying memory and also foundry technologies to solve the memory wall. Okay, so if you're interested, come talk to us as well on that. I briefly introduced the 2.5D packaging. Later, again, at our booth, you will see also a sample of 3D packaging. That's what we call X-Cube. And of course, all of this is not possible without an ecosystem, right? So on top of us basically working with you, we also have the cloud ecosystem, EDA ecosystem, many IP ecosystems, some of them here in the room. And also to support you in design, we also have design partners, whether full turnkey design or just basically design engineering services. Again, I met many today, so I think I highly encourage you to also talk to us. Yeah? So again, relevant to RISC-V, some of these are the published success stories that we have done in the last couple of years, right? Sci-Fi and Samsung Foundry has been working for a long time, right? I think since the first project started at 14 nanometer, if I'm not wrong, right? Where we co-developed an AI accelerator platform. 10storon is one of our customers as well that we have announced. As you know, 10storon is super active in the RISC-V community. They are actually using our 4 nanometer that I described earlier. They are, again, a rich lineup of additional customers at 4 nanometer that we have not announced yet, but we are super excited seeing the traction for RISC-V using our technology. Another partner that I would like to call out is Semi5. Semi5 is a design solutions partner of ours. They have full turnkey services and capabilities. So they have been fabricating a number of platforms using our 14 nanometers. Yeah. Okay, just to wrap up, so I shared with you some trends and challenges. So AI model sizes has scaled many orders of magnitude. We need more compute, non-sustainable power consumption. So basically, we need more energy efficient solutions. We have a memory wall to overcome. I've showed you HBM custom base die as one possible solution to address this. Again, hopefully, the simpler presentation, you see that we continue to invest in a broad and deep technology roadmap to service the customer base. And with our advanced packaging solutions, and including potentially custom memories, we can be a one-stop solution provider for you. So simple call to action is come over to our booth over there. We'll be here today, tomorrow. Talk to our subject matter experts. All right. With that, I've closed my presentation. Thank you. Yeah.